Before we create our post-process volume that we'll use to apply our post-process materials to, let's get rid of the current post-process volume. In order to do that, if I go to the World Outliner and I type Post, I'll filter out any post-process volumes in the scene. I can see I currently just have the one. So if I make sure it's selected and then just delete it, it will be gone. Now, not much has changed, except that if we look at the bright area of the scene and then again at the dark area of the scene, I'll notice that things are gradually getting brighter. And that's because by default, without a post-process volume to turn it off, eye adaptation is turned on. So we'll need to make sure to turn off eye adaptation with our new post-process volume. So now if I browse to the Modes tab, down to Visual Effects, at the very top I can see post-process volume. If I left click and drag it out, I can place it anywhere in the scene I'd like. So let's name it PPV_materials. And now under the post-process volume settings, let's set infinite extent unbound to be checked on, which will apply it to the entire level. In order to turn off eye adaptation, if I go to the Lens tab and I expand the Exposure tab, I can see I have a min brightness and a max brightness. If I check both of those, and then I set them to the same value, we'll set it to 1. Now when I look at the bright areas and then at the dark areas, I can see that my eye adaptation has been turned off. Also, we notice the scene is quite a bit darker. And that's because in the original post-process volume, we had an exposure compensation of 3. So if we check that box and we change the default value of 0 to 3, now we have something that looks very similar to our original scene. However, for our post-process materials, we don't want to have an exposure compensation brightening them in post. So let's turn that back to 0. The next thing I'm going to want to do is go to my Rendering Features tab and expand Motion Blur. If I check the amount, I can see the default value is 0.5. Let's set that to 0 because in traditional animated films, there isn't motion blur. And we'll leave this setting for the remainder of the course. Also under the Rendering Features, under the Post-Process Materials tab, I can see where I have the ability to apply my blendables. In Unreal Engine, there are 3 blendables that you can choose from. And if I click this plus button and then expand this menu, I'll see I have the choice to choose between a light propagation volume blendable, which we won't be concerned about over this course, or an asset reference. And an asset reference is going to allow us to choose either a master material or a material instance. Now that we have a designated post-process volume that we can apply our blendables to, we're ready to create our first post-process material. But before we do that, in order to get a better understanding of what we're doing when we extract our G-buffer, let's take a look at a buffer visualization. If I browse over the Lit button and I left click, at the very bottom I can see buffer visualization. If I select Overview and hit F11 to go into full frame, I can see I have my base color in the upper left-hand corner, as well as all of the other G-buffers that are making up the current rendered frame that we see in the center. In order to extract the base color, if I hit F11 to exit full frame, let's create a material. In the content browser, in the root, I see I have a post-process folder. In the root of that folder, if I right-click and then I browse up to where material is, and then I left-click, I can create a new material. Let's call it PPMM, which is an acronym for Post-Process Master Material _ Base Color. If I double left-click to open this material, I can see I have a blank material that has all of the inputs of a PBR material. Now by default, if I go to the Details tab under Material, I see the material domain is set to Surface. If I left-click this menu and expand it, I have several options, one of which is Post-Process. We're going to want to select this to make this a post-process material. Now once the material domain is set to post-process, I can see that all of the pins, except for the emissive color, have been grayed out. The reason for this is because a post-process material will only allow you to overlay the RGB values on top of the render. This is done through the emissive input. So now, in order to grab our base color G-buffer, we need to do this through a scene texture material expression. So anywhere within the blank space, if I right-click, in the Search tab, if I type Scene, I can filter out any material expression with the word Scene in it. And under the Texture menu, I see I have 2 options, Scene Color and Scene Texture. We're going to want to choose a Scene Texture. So now, under the Details tab of the Scene Texture, I see I have a Scene Texture ID menu. And if I left-click to expand this, I see here all of the G buffers that correspond with the G buffers that we're seeing through the visualization in our frame. So let's choose base color as stored in G buffer near the bottom. Once that's selected, if I drag from the color pin and plug it into the emissive color and hit save, we can apply our material to our post-process volume. So let's minimize that. Let's make sure that we have our post-process volume selected. Under the rendering features, under my post-process materials array, let's select our asset reference. So now I'll see I have the ability to input a material, making sure that I have my PPMM base color material selected. If I left-click the arrow, I notice here in the center of my frame, let's hit F11 to get a little bit of a better look, that I currently have the base color overlaid on the scene. So let's exit the buffer visualization now. Go back to the lit option to see this in full frame. So now that we have the base color on the scene, we're noticing that the image is jittering very badly. And the reason for that is because by default, Unreal Engine uses what's known as temporal anti-aliasing. And at a high level, what temporal anti-aliasing does is jitter the image and average the result back on top of itself to solve for jagged edges or jagged details inside the material surface. So let's hit F11 to exit full frame up on our mannequin to get a better view. And in order to solve for this, there are a few things that we can do. One of the things we can do is we can change the method of anti-aliasing. So if I browse to where the edit button is at the top and go down to project settings, under engine, if I select rendering, and then in the rendering tab, if I browse down to the default settings, I can see I have an anti-aliasing method set to temporal anti-aliasing. If I expand this, I see that I have a few options: none, FXAA, temporal AA, and MSAA. So MSAA is only going to be supported with forward rendering, and because we're using the deferred renderer, that's not an option we're going to be concerned with. We've already covered what temporal AA is doing, and FXAA is a different form of anti-aliasing known as fast approximate anti-aliasing. So if I select this and I look at my image, the jittering has stopped. However, we still have jagged edges. Now, the reason the jittering is gone is because of the way FXAA works. FXAA uses a depth algorithm to find the edges of surfaces. Then it allocates its pixel blending algorithm to solve the aliased edges along those edges. It doesn't concern itself with anything inside the surface of objects. Temporal anti-aliasing will. So let's turn this back to temporal AA. Our jittering will come back. And then let's close out of the project settings. So now in order to get rid of this, we're going to need to go back into our material. If we double click and open our material and we select our root node, we can browse down to where we see post-process material, which is going to be towards the bottom of our details tab. And under this menu, we have a blendable location. And next to that, we see it's currently set to after tone mapping. If we left click to expand this menu, we see a few options. After tone mapping is going to extract our G buffer at the very end of the post-process pipeline out of low dynamic range space. Before tone mapping is going to extract our base color in high dynamic range space. Before translucency is going to be before any translucent effects are applied to our image. Replacing the tone mapper will disable the tone mapper entirely if you wanted to create your own. And screen space reflection input will use whatever the G buffer is as a screen space reflection. So if we change this from after tone mapping to before tone mapping, and then we hit save, we can now see that the jittering is gone as well as all of the jagged edges. These are going to be the settings that we're going to want to use for the rest of this course. We now have a designated post-process volume that we can apply post-process materials to. We also created our first post-process material that renders the base color onto the entire scene. In the following modules of this course, we'll examine how to use post-process materials to generate outlines.